Microcontroller technology continues to be critical to the development of our applications as engineers. With the demand for microcontrollers expected to nearly double by the end of the decade, their importance for the next generation of technology cannot be overstated. With so many semiconductor suppliers standardizing on ARM as the CPU for their MCUs, sifting through the strengths and weaknesses of the options can be a challenge. Has the microcontroller become commoditized, or are there still significant differences and innovations in the latest technology that we should be considering when we select the right part for our designs? Personally, for me, I think I really fell in love with electrical engineering when my sophomore year in college, when I took my first class on microcontrollers. And back then I was studying the Motorola 68332. But when I started getting into the code of that and being able to make a microcontroller do the things that I wanted it to do on that board, I really just fell in love with our discipline in that moment. The world has changed a lot since then, back in the mid 90s, and what has happened. I mean, just look at the automotive industry. If you were to buy a car in the year 2000, there were probably about 30 microcontrollers in that vehicle. If you bought a car, even the base level vehicle today from any of the different manufacturers, there are probably 3 times or more that, 100 MCUs or more in those vehicles. The microcontroller has changed the way we do all of our designs. And now we're moving into a next phase of microcontrollers in our designs where we're starting to ask them to do artificial intelligence and machine learning. We're asking them to do machine vision. We're asking them to be more intelligent, faster, lower power. And there's a lot of asks here in the market, but how do we as engineers decide what's the right microcontroller for the design that we're working on? That's always a very common question that we work with engineers on a daily basis. Today I have the privilege of speaking with Daniel Hou, who's technical marketing engineer at NXP and is a fellow engineer who loves microcontrollers, and I know has spent a lot of time with them being at NXP. Daniel, thanks so much for joining me on The Current today.
Hey, Todd. Thanks for having me on the call. A very good privilege for me to be on this broadcast. I'm calling in from Austin, Texas. Nice weather over there.
Yep. Right where I am. So we have a beautiful day here in Austin today. It's not too shabby. Spring has arrived, so it's definitely a good place to be. So again, I can't thank you enough for being here, and I really appreciate you letting me pick your brain a little bit. So let's start what I think is kind of the foundational question right now when it comes to microcontrollers. Over the course of the last 15 years, or maybe even a little bit more now, we've really seen ARM dominate microcontrollers across all suppliers, and it seems like every supplier out there, if you're looking at a microcontroller in the options, you're going to be looking at an ARM core, a Cortex-M, or if you're going to a processor, a Cortex-A. With that really being the identical piece of pretty much every single microcontroller out there, really the only differentiation is in peripheral sets, memory size, and things along those lines. How have companies like NXP really differentiated yourself to show that, yes, we're an ARM-based microcontroller, but here's why we are doing the implementation a little bit stronger than some of our competitors?
Well, that's a very good question, Todd. I think back to your point where you mentioned about your students, right? I think you and I both, I graduated as a electrical engineer student,
Yeah.
and I remember my first embedded system design class. We a Motorola MCU that's their own core.
Right.
And now, soon enough, when I entered the industry, everybody starts to invest in ARM, and nowadays you cannot really avoid talking about the ARM core.
Yeah.
In our so that's inevitable. And then, so to your question, I think there's also, you mentioned about the level of complexity, right?
Right.
So you mentioned about cars in the old days, car nowadays. We're seeing the same thing with our customer base. And if you look at the complexity here, it's not like the old days that you only look at the core speed, what kind of peripherals you offer. You check the data sheet, right? Like
Right.
you're shopping in a supermarket and you find the right answer for you. Those days are long gone. So basically, what you're facing right now is different levels of complexity, and the first layer is the hardware foundation. That's still like our bread and butter is the chip manufacturer. So
Right.
the hardware platform that we design. And then, so to your question, I think there's also, you mentioned about the level of complexity. And the first layer is the hardware foundation. That's still like the our bread and butter is the chip manufacturer. So the hardware platform that we design. all the features needed in there. But on top of that, there's also requirement from a specific technology or function. For example, if you're doing motor control, if you're doing machine learning, if you're doing sensor interface, it's not as simple as driving peripheral or driving the core with some software.
Right.
So you need to build upon your hardware foundation. So that's the required technology. And by combination of technologies or different functions, you have full blown at that level. So, for example, if you're talking about a coffee machine, as simple as that, you have a screen that you need to interact with. So that's a machine interface HMI. You have a pump that you need to control. That's motor controlling there. So it's always a combination of different kinds of functions or technologies that form the end for our customers. So basically, as we are addressing those three layers of complexity by combination of hardware and software. So from hardware wise, aside from the ARM core, you're seeing us putting more and more intelligent peripherals or even a co-processor or accelerator onto our chip.
Right.
If you look at some of our newer chips, they also have things like even the DSP accelerator, the GPU, or even the neural processing unit for machine learning integrated onto the chip. So that level of integration was from a hardware foundation level to enable those corresponding technologies. Then from a software perspective, we're enabling our users to basically utilize our ecosystem, the MCU Espresso ecosystem, with a variety of IDEs, different kind of SDK examples. We're at new application roadmap. We can get into details later in that. So basically, it's a total package that we offer now instead of a single.
Right. Right. Yeah, I think the fact that you've got families of devices that if you use one device in the MCU, you've got a whole family of devices that you can use around that. I think that's important as well, and certainly something that we've seen with engineers where they know they're not just designing the product that they're working on today. They're probably going to reuse a lot of that circuitry and maybe even standardize on an MCU family to use on completely different products down the road. When an engineer is looking to really figure out, okay, this is I want to use this family of NXP microcontrollers for the next 3, 4, 5 years and really get familiar with it and use it across 4, 5, 6 products. What do you think the things they should be considering when they're selecting the right family to go with?
Yeah, absolutely. So first of all, you need to look at your application requirement. That's the thing to begin with, right? That's
Sure.
that's where
Got to
everything
start there.
starts.
Yeah.
You gotta have the right members in your MCU portfolio or your MCU family, so the user will be able to use that for their application. But aside from that, I think as a user, you also need to look at things like, for example, longevity of the product, right? You don't want the product to be EOL just after 5 years or even 10 years is now even considered shorter for a
Right.
lot of users in the industrial space. We're seeing medical customers who require their longevity to be around 20 to 30 years. So that longevity will provide the user the capability and the confidence to design with the product. But also, you need to look at scalability. So scalability is a key factor if you are trying to design, for example, make your whole product line using the same family of MCU or same series of
Right.
MCU. So you can basically, minimize your time to market, minimize your design effort across your whole product portfolio by using the same kind of MCU family. So that's basically scalability hardware features where you have a unified series of MCUs that has a variety of different features offered. So you can use different kind of members in your different kind of product line, but also scalability terms of software where you can basically reuse most of the software in different product lines within the same kind of MCU
Right.
platform, MCU series.
Right. I mean, where does tool set play into that? Because I think that's a key part as well. Is when we're looking at the hardware of a microcontroller, that's great. We've got that on our board, but where I think most of us as engineers live is in that tool set and where we're writing our code. How does that factor into the selection? Do you think?
Absolutely, absolutely. I think in my own experience in using a lot of MCUs, I started off as so I use a lot of MCUs. It is not the tip you're looking at, right? It is the whole hardware, the software ID, the coding, everything that on your computer screen that you're looking at when you're really developing your firmware. So that requires us to have a very unified, software platform. You need IDE offering, and that's also not limited to your own IDE from the company
Right.
that you use, by the way. You might be using IR, you might be using even Visual Studio. So all those different environments that you enable them. So the user has power of choice when it comes to the development environment. But also there is this abstraction layer that you're building upon your hardware, where let's say you're simply like you are the R squared C,
Right.
you shouldn't expect that part of the code to just apply that to the MCUs. There's hardware abstraction underneath your user code or your API, so that to ensure that if you are using, for example, a UART or iSquared application, it's seamless across the platform. And that's, frankly, that's what we are trying to do as a company, is to enable that hardware abstraction for our users, so that if you switch to one MCU from us to another one, um, it's more seamless.
Right, right, and that can't be understated or overstated. Actually, I think just from the standpoint of if you're having to spend time every time you're doing a new design just to figure out how to get the serial ports running, and you're having to spend a lot of time on that portion of code rather than just having it done and being able to port that easily from design to design to design, it really can be a time sink. So that's incredibly powerful. Going to more complex type of applications and more complex technologies that we're getting into engineers. We talked about machine learning a little bit. That's an area that I know I'm trying to get up to speed on. Our engineers at Future are trying to get up to speed on. We're trying to help our customer engineers get better and better at how to implement machine learning in embedded applications. What tools and things does NXP doing to make that easier for engineers?
Yeah, that's actually a very good question. I'm myself. I mean, I'm also very interested in machine learning. I did some machine learning course and study during my student years.
Yeah,
Back then, we were using MATLAB.
right.
That was not industrial friendly.
No,
There's no way for you to download your code onto a single chip MCU or even like a processor, right?
right.
So that's the old days. Nowadays, I would say the upper level software is more embedded world friendly. And then, as a company, we're really trying to create that. If you look at all the machine learning tools out there in software, you're seeing like Python, you're seeing a lot of different tool chain, different framework that could be, you're seeing things like TensorFlow Lite, for example, that's very friendly to an embedded system. So we're also leveraging that, and then building our own tool chain to enable that. So if you are familiar with the machine learning technology, it's basically at the end of the day is math. It's a tons of multiply and tons of accumulation in your system.
Right.
And we're really talking about machine learning at the edge, meaning that you're not really using your microcontroller to train the whole model. Usually that's done by done by your computer, and then you basically download the inference, which is the model itself, onto the microcontroller,
Right.
and that's where really the microcontroller shines. It's a real time platform, so you can utilize your model in your real time, sensing and then making the judgment based on the machine learning model.
Right.
So So in order to do that, you need a full suite of tools, really,
Absolutely.
aside from the MCU itself. Theoretically, you can do machine learning on any kind of computing platform. You can use the ARM core to do it.
Mhm.
You can use some GPU core to do it. But as a hardware foundation perspective, we start to put really compact neural processing unit onto the device as a co-processor for our MCUs. Take an example, our new in production XTX N series. They have a neural processing unit on the chip, and that's basically our most compact neural processing unit. And we're trying to also build the scalability story around the neural processing unit itself, where you in the future you will see that to be scalable from our lowest cost, most compact device all the way to, for example, the Atom Max processors
Right.
that's running on Linux.
Yeah.
So we're trying to build, yeah. So we're trying to build a unified and also scalable hardware platform for it. So on top of it, we also have a unified software suite. We call it the EIQ toolchain. Basically, the toolchain, what it does is really simplify the way that you are downloading your model or you deploy your inference onto your hardware platform. So that could be, we have different kind of workflow that suits different kind of users. Some users are more sophisticated with
Sure.
machine learning. They might use their own like TensorFlow-like trained model.
Right.
They like to deploy that inference. So the tool provide a workflow like that. Some other users that might be new to machine learning, and the toolchain itself also offer some well-used or popular models in the market out here. So you can basically directly utilize the model to create your own, proof of concept machine learning application using the toolchain.
Right.
And that also pair with the hardware development platform that we have for quick prototype.
Right, right, and those kinds of tools are invaluable. I mean, having that in an entire ecosystem where you've got the one provider of the hardware who also owns a lot of the tools that make that hardware bring up an ML application. I think it's
Yep.
really powerful for engineers because you don't end up in a situation where it's like, no, it's their fault. No, it's their fault. It's got all NXP working on that. So if there are issues, if the customer's trying to learn it, it makes it so much easier to really have a one-stop shop for the hardware, the software, the development tools to make their machine learning applications sing, which is where we certainly want all of them to go. Other than machine learning, the other thing I'm a really strong believer in, and probably machine learning is part of this as well. But I really think that over the course of the balance of the decade and beyond, we're going to see a real rise in automation, which I define automation as the removal of people from processes, is really what I look at it as. And I think that is going to continue to accelerate. We're going to want to see more and more of that in the world. And I think in a lot of ways, we won't recognize the world in some of those things in 10 years. And a lot of that means motor control. You've got to have your system not just be able to interpret the environment that it's in, but actually manipulate the environment that it's in robotics form or other different types of form. But motor control is going to be part of that. How is NXP addressing motor control and the needs in the industry and helping engineers speed up the process of doing their motor control designs?
Yeah, so you're absolutely on point. I think motor sits in the heart of automation, right? If you think about automation, that's everything that's moving, powered by electricity, then that's motor.
Right.
So motor control is also one of our focus technology uh, for our company, NXP. And same with other technology we focus on. We enable not only from the hardware perspective, but also from the software perspective. So from hardware perspective, you're really looking at you look at the MCUs right now. The motor control to me is about be fast enough in terms of processing, right? It's a lot of real time processing. It's a lot of real time algorithms that's running, and also waveform and also sensing capability, right? You're sensing, you're doing a control loop, so you're sensing from the motor, and then therefore you do some processing, and then you go back and control the motor respectively. So that involves, for example, like high speed ASIC converter that we have integrated into our MCU. that involves a high efficient core.
Right.
If you look at our product line of the MCUs, we're probably one of the most scalable MCU providers out here that provides you all the way from a Codex M0 Plus platform for low cost entry level design, all the way to our Adamax RT, which goes up to 1 gigahertz of performance.
Right.
So that goes into, if you look at factory automation, if you look at like servo robotic control, that you need that kind of processing horsepower there. Some people nowadays are trying to use the processors running on Linux for that as well. But don't forget that the MCU still have a natural edge when it comes to motor control because it's a real-time platform. And motor control is a real-time control loop. So by using a high-speed MCU, naturally you gain a real-time perspective of the whole processing capability.
Right.
And also in terms of waveform output or PWM output, we have dedicated peripherals that automatically produce the waveform to control, for example, a three-phase motor, or to control a full bridge, to run a brush DC motor as simple as that,
Right.
or a BLDC motor. So those peripherals are easy to be configured. It has a lot of built-in functions in there, even with some functional safety related functions like auto shutdown, auto restart. Really reduce your hassle of going into design with motor control. All you need is a simplified gate driver with your MOSFET to control the motor, and that's it.
Right.
So that's more to the MCU. And then from a software perspective, that's the same story where we have an integrated SDK called Motor Control SDK, where you can do even a motor control modeling, where it's actually really fascinating. When I see our demos, it's you use any kind of motor, and then you pair that with our development platform with the MCU on board. And you use our toolchain as a real-time debugging tool called FreeMaster, and you can kind of inject some pulse into the motor, and it will figure out parameters to start with for the motor tuning itself.
Right.
It's almost like and the user basically jumpstart from there, and then fine tune their motor to the next stop. We understand that the user always want to add their secret sauce in their design
Of course.
for their right. Our mission is really to provide a platform to get the user as easily as they can to the step where they start to add their secret sauces, and that's through the whole software suite.
Right.
And it's very interesting that you mentioned additional newer emerging technologies with motor control, and you also mentioned we also talked about machine learning,
Right.
and that's frankly speaking that's playing a very big part in automation and motor control as well.
Sure.
And that goes into anomaly detection, maintenance of the motor. We have done some study on, for example, the factory. If you look at the factories nowadays, I don't remember how much percent, but a huge amount of factory downtime are contributed by a motor running out something. So the factory needs to be shut down. That costs tons of revenue loss for the manufacturer. So if you can predict that kind of from the motor, then back then as simple as this current from the motor or simple vibration, and then train that, then your MC automatically realize that there's something wrong with the motor bearing or something like that. So you can shut down the factory or pause the factory in a relatively less time,
Right.
so that definitely avoid a lot of revenue loss for the manufacturer. So that's definitely we're seeing a big usage of that with our MCU in motor.
Yeah. Yeah. And that's incredible. I mean, those kinds of tools are really invaluable. Again, going back to your comments about MATLAB, I remember spending a lot of time in MATLAB trying to figure out how to fix the algorithms for my motor controls and eliminate ringing and overshoot and all those other fun things in my PID loop. So having that done in other tools would have made my life a lot easier back then. So I think that's phenomenal that's available now. It's going to expedite designs a lot.
Definitely.
So, as we're talking about this, I know one of the exciting things at NXP has been the launch of the new MCX family, and so kind of taking the LPC series that you guys have and the Kinetis series that have been around for a while, and now really kind of pulling out the new MCX series of microcontrollers that I think is a great new direction for NXP and is going to bring some exciting things. I know the two big ones are the MCX-A, which is probably more geared towards a lot of industrial applications and some motor control, and then you got the MCX-N, which has got the built-in capability to assist with machine learning applications. What are some of the hardware tools that you guys are making available so that engineers can quickly get up to speed with those two new family members?
Definitely. Well, I mean, the entire company is thrilled and excited about the MCX series. So we build use switch that comes with the we actually uh, renouncing the free. If you are a that user, a free platform for the early days, but now for the realize that people need a easy to use low cost platform for the so that's the freedom. And the reason we call it freedom is because you really get this flexible, rapid prototype
Yeah.
implement with the board, where the board will have some basic onboard debugger, onboard programmer, some buttons for you to LEDs, of course. Who doesn't love LEDs? And to have you like jumpstart evaluating the MCU, but more importantly, all the different headers that it provides. Look at Arduino headers. If you look at microelectronica headers for the clipboards, PMOD headers,
Yeah.
we have all the headers on the board. So think of it almost like a baseboard for your Lego project, right?
Right.
You're basically gradually adding different functions onto your platform through the add-on boards. For example, if you need something as a sensor, then you have uh, board and then you plug it in. Then you have you control. We even have our in-house freedom with some in-house freedom shield that looks like Arduino with additional pinouts, so that you utilize that freedom and freedom to do more complex, motor control, like capacitive, all those kind of different. And you have access, for example, to your parallel camera. We talked about the MCX-N that has the machine
Right.
learning capability. We have a nice demo where you basically use the Freedom board along with different modules, like the parallel camera. We have the
Mhm.
module for the LCD. So you create a facial detection demo just by adding two add-on boards to the Freedom base.
Right.
So that shows really the capacity of the design platform. And the board is at most $30 right now. If you look at the MCF, that's even a cheaper board. So everybody can get the board. And based on you basically add your Lego blocks on top of the base board and create your own application as a proof of concept.
Right, right. I love those kinds of. They're wonderful for proof of concepts, and it really is impressive. I'm really glad to see those low cost boards available, so engineers can really do a lot of their design before they even have to go to schematic and layout and get boards back from the board house. They can prove out that the idea they want to actually be their application can work. And we absolutely love that NXP's released this. We've got obviously the Freedom boards available for customers. We also have all the different click boards available to help customers out with, and would love to help integrate those together for any engineers that are looking to do that. So that's wonderful. Really excited to use this boards. I know every board, every engineer at Future Electronics is being equipped with a number of those Freedom boards. So we're happy to get out there and show them off to customers and get them in customers' hands as needed. So Daniel, thank you so much for joining me today. Really interesting stuff. Again, you share my passion for microcontrollers. That always is something that I really enjoy talking to somebody that does share that passion, because not everybody does. So I really enjoyed talking with you today. Thanks so much for being on the current.
Same here, Todd. Same here. I really enjoyed being on the podcast. It's great with a lot of innovative ideas to our crowd. Really excited fun with the board.
Absolutely, absolutely. So, also thanks to our audience. Really appreciate you joining us for the current today. I hope you found the episode interesting and found some good nuggets of information about where the microcontroller industry is going and some of the options that Future and NXP have to help you in your microcontroller designs. If you have a design that you're working on where you're interested in utilizing new microcontrollers, you want to evaluate the different microcontroller options that are out there. Our engineers would absolutely love to meet with you, have discussions with you, and find the right microcontroller for your application. Again, we've got a lot of the NXP Freedom boards we would love to come out and demonstrate to you and also help you with any of the click boards that you might need in those applications. Please reach out to us if you have a need at Shaping the Future, one word, Shaping the Future at futureelectronics.com. Send us an email. We'd be happy to get back with you and have one of our engineers meet with you, demonstrate some of this product and the great stuff that NXP has coming out. Thanks again so much for joining us on The Current, and we'll see you next time.